So in this section, we'll be using the fundamental theorem of calculus. And what it says is let f be continuous on the interval from a to b, and let capital F, the original function, be any antiderivative of f. So the derivative has been taken, and we're going to go back and find the original function. Then the integral from a to b of f of x dx is the original function at b minus the original function at a, and it's written capital F of x, b to a. Okay? Now, a is the initial point, b is the end point, but when we find the distance between those two, we go f of b minus f of a. So you have to go in reverse order. So for our first example, the integral from 1 to 6 of 6 dx is going to be 6x evaluated from 1 to 6, but we go 6 times 6 minus 6 times 1. So end point before initial. Okay, this is the last point. This is the first point. Right? So if you're moving from 1 to 6, you do this one first, back to this one. 6 minus 1, in this case, is 5. But up here, it's 36 minus 6, which is 30. And there are a lot of fantastic applications of the antiderivative in this case. And we also call this a definite integral, okay, a definite antiderivative, because we know what the beginning point and the end point is. So we're going to evaluate the integral in question number 14 from 1 to 3 of 2x plus 8 dx. So we're going to split this apart from 1 to 3, 2x dx plus from 1 to 3, 8 dx. So this first one would be 2x to the 1 plus 1 divided by 1 plus 1, evaluated from 1 to 3, and then 8x evaluated from 1 to 3. So that's going to be x squared, 1 to 3, plus 8x, 1 to 3. So it's going to be 3 squared minus 1 squared plus 8 times 3 minus 8 times 1. So that's 9 minus 1 plus 24 minus 8. So that's 8 plus 24 minus 8, 32 minus 8 is 24.